Hello everyone, welcome back to Enginuity Lab. In today's video, we are moving ahead with part 17 of our CATIA V5 beginner series tutorial. In this session, we will practice a sketch based feature exercise which we are doing from last 3 sessions. Today we are going to create another 3D model, that is the Android symbol. We will create this symbol in 3D model. So let's start. Go to start, mechanical design and part design. Now give the name. Here I am giving the name as Android symbol and click on OK. So let's analyze the sketch first. Here this section, this is first we will create this section which will be 50 mm in diameter, and then we will create this legs, and after that we will create the head of this symbol and the ears, and then after at last we will create the hand. At the last we will create this pocket. Using pocket tool we will create the eyes. Okay, so let's start. For this one, this is of 50 mm and the height is 46 mm. You can see from here, so it's 46 mm height and 50 mm in dia. So let's create. For that I am selecting this face YZ plane to create the sketch. We are into the sketcher workbench. Here I am going to create the half section of this. That will be like this. This is only the half section. Like I will create this section only. Okay, so this is 25, 46 and here are 2.5. Okay, double click on the constraint, give the dimension. This is 25, this is 46. Okay, and here the radius is 2.5. Double click on the radius, 0.5. Now my sketch is created and it is fully constant. Go to exit workbench. Now we are into the part design workbench. Here I am going to use this tool, that is shaft. So I will use the shaft here. First select the sketch. Sketch is already selected. This is sketch 1 which is already selected, and the axis. To select the axis I am select this line, click on OK. Now first one is created. Okay, let's go. What to do next? Next we will create the legs. For that, here I am going to select this face, click on the sketcher tool. I will create 2 circles here. This is 12.75 away from the center, and this is 12.5 mm dia. So both are 12.5 mm dia, and this is symmetric about vertical axis, allow symmetry line, and this one is So let's give one dimension only, 12.75. Okay, and the diameter will be 12.5 for both. So I will give dimension to this one. Click on this, click on this circle and right click. Yes, it's not allowing to make it equal, so give the dimensions again and 12.5. Okay, now click on the exit workbench and what is the length? This is 11 mm and then the radius. So this will be 11 mm plus 12.5 half. Use the pad command. Length will be 11 plus 12.5 divided by 2. Now our length is created automatically. You can use the calculator tool as well here. Okay, so up to this it is complete. For next one, up to this much this is complete. So next one we will create the head of this. So this will be, I will create this section, the half section of this one. This is radius 25 and as you know this is 50. This is same for this one as well, and here the radius is 25. So I will select the YZ plane, click on the sketch, so let's click on, to create the head portion I will click on the ZX plane, click on the sketch tool. Now we are into the sketcher workbench. Here I will create this one, and this is my profile to be create, and let's keep the dimensions here. Here this is 3.8 mm from the baseline. Okay, this one is 3.8 mm and this radius is 25 mm. Okay, this is also 25 mm and here this one actual 25 mm. This length is also 25 mm. Now my sketch is created. So click on the exit workbench, use the command shaft and then select the line or the axis. For this I am selecting this vertical axis, it's my axis. Now you can see up to this it is created. The head is also created. Now click on the ZX plane. Next one is to create the ears. For that this is R.6, this is 30 mm length and 1.5 is the thickness and 16 mm apart. So I am selecting this plane, the ZX plane, click on sketcher tool, and here I am creating this shape. I will create an arc here, 3-point arc, or use 3-point arc, first point, second point, the 3-point arc which have first point, the second point, and the third point. Okay, and also here also I will use the 3-point arc and give dimension. I want this line I will create a simple line here. Okay, this is 1.5 mm, and I want this line to be tangent, and this then tangent to here. Why this is over constant? Let's see. Just make it again. This is the tangency. I want this actual tangent, and now this is, we don't need this one, because when we give this dimension, then this will create automatically. And this is, the length is 13 mm. Now up to this it is created. So how I can go up to this? Here I will delete this one, and I am going to create a circle here. And the circle is of 50 mm diameter, and this is coincide with this line, and also this line is coincide at the vertical axis. Now, and I want these points to be coincide to this one. Now give the dimension to this. This is 13 mm. This point is also coincide to here, and here I want axis, and this is to this point, this is 8 mm. So what's left? And this is 30 degree. So let's give that dimension, the angle. This is 30 degree. Okay, now our sketch is fully constant. We have one thing left. We need to trim this and this portion. Now we are going to use the mirror command to create the mirror of this sketch. click on the mirror. First select the object, then click on the mirror and click on the center line. Now our sketch is created. So click on the exit workbench. Okay. Now use the pad command and mirror extent. I want this edge only 2 mm. Now this is created. Okay, ears are created. So next one is to create the hands. Ears are created. Next to create the hands. For that, this is of 64.2 mm apart from each other, and this is 3.6 radius, and the length is 30.8. Okay, this is 30.8 and 64.2, and this is 6.6 mm from the headline. So here click on the ZX plane, click on the sketch tool. Now we are going to use the elongated hole option. Okay, click on the elongated hole, click on the first point, click on the second point and give the radius. This is the elongated hole we have created, and R is 3.6. So this is the R. You can use 3.6 here. This is 6.6 apart from the headline, the center point 6.6. Okay, and this line is 30.6. Let's check. 30.8. Okay, and this is 64 point something, 64.2. So we will calculate 64.2 divided by 2. Okay, let's see. This gives the automatically. This calculates automatically. Okay, and I will give this line here and just remove this one and click on the quick trim, and now my profile is created. And this will be we will do this one using the shaft command. Click on the exit workbench. Now where the sketch created, use the shaft command. The sketch is selected already. Select the axis as this one, click on OK. Now one hand is created. Here I not cover the mirror command in 3D models. Still we will use the same. This is same as the 2D mirror command. But one difference, we can use this one in 3D as well. Click on the mirror command and select the object to mirror. Here I am selecting the shaft and mirroring element. Mirroring element means here we don't need to select the line. Here we have to use the plane. Here I am using this plane. Okay, and click on OK. Now you can see the hands are also created. Now we have the eyes left. We need to create the eyes, which is 5 mm diameter, 14 mm from the baseline and 11 mm from the center line. So what we will do, we will select this plane, ZX plane, click on the sketcher tool, create two circles, one is here and another one is here, and this is symmetric about the vertical line. Both are have 5 mm diameter, and this is 14 mm from the baseline, and this is 11 mm. Okay, now we have the eyes created in sketch. Click on the exit workbench, use the pocket command and up to next I will use and reverse the direction. Now I have the eyes created. Okay, so everything is created. Now our 3D model is created. The Android symbol is created in 3D model. So in today's session we have created a 3D Android symbol. So if you find this video helpful, don't forget to like, share and subscribe to Enginuity Lab for more CATIA V5 tutorials. In next session we will advance to another tools or another set of tools, that is called dress up features. We will learn about the dress up features first, then we will explore the dress up feature tools one by one. So thank you so much for watching Enginuity Lab. See you in next video.